This thin section shows irregularly shaped grain boundaries. The rock is composed of interlocking crystals rather than grains that are rounded or angular in shape. The rock shows a foliation because some of the grains have a parallel arrangement, giving the rock a striped or banded appearance. This is more obvious in hand specimens of this rock. This rock is probably a metamorphic rock. Most of the grains are between 0.1 mm and 2 mm in size, so the rock is described as a medium-grained rock. Under plain polarized light, the rock can be seen to be made of 4 main minerals. 2 of these form grains that are colourless or slightly cloudy grains, and they have a low relief, which means that most of them do not stand out from the section any more than the other grains. These minerals, which do not change colour as the stage is rotated, are the minerals quartz and feldspar. They are best distinguished under crossed polars. The colourless to pale brown coloured mineral, which forms equidimensional crystals and has curved fractures, is garnet. It shows high relief and it is not pleochroic. The green mineral with high relief is hornblende. Hornblende is a type of amphibole. Basal sections of hornblende show 2 cleavages at 56 degrees and 124 degrees to each other. Prismatic sections of this mineral show just 1 cleavage. Cleavage in hornblende is best seen under higher magnification. Here is a basal section showing the 2 distinct cleavages, and a prismatic section showing 1 cleavage. The cleavage in the prismatic section is less well defined. Under higher magnification, it is also easier to see the pleochroism, that's the colour changes in different sections of the hornblende as a stage is rotated through 90 degrees. In this basal section, the hornblende is a straw yellow colour when the section is north-south. The same section is darker, a darker blue-green colour when the section is east-west. And the same section is just a green colour when the crystal is halfway between these 2 positions. You'll notice that for the prismatic sections, it has a darker colour when the section is in an east-west direction, and it has a lighter colour when the crystal is in a north-south orientation. There is also an accessory mineral called Sphene. In plain polarised light, it forms brownish coloured, diamond-shaped crystals with very high relief. It also shows pleochroism as the stage is rotated. Under cross polars, it is easy to distinguish between the quartz and feldspar grains. Quartz is identified by its first-order grey interference colours and lack of twinning. Feldspar is recognised by its first-order grey interference colours and twinning. This feldspar grain shows multiple or lamellar twinning. Rotation of the stage in one direction results in the sets of lamellae going dark and reaching extinction. Rotation in the other direction results in alternate lamellae reaching their extinction position. Notice that the mineral has an inclined extinction. This means that the mineral goes extinct when the elongate direction of the mineral is neither east-west nor north-south. Under cross polars, the garnet is isotropic, which means that the garnet crystals go black. Hornblende is recognised by its up to second-order interference colours. It also shows an inclined extinction pattern. The Sphene crystals under cross polars show high-order cream and pearl grey colours. In summary, This rock is made up of a mass of interlocking crystals 0.1 mm to 2 mm in size. The rock has a foliation and is a medium-grain crystalline metamorphic rock. The main minerals making up the rock are an amphibole mineral called Hornblende, plagioclase feldspar, quartz and garnet. Sphene also occurs as an accessory mineral. Note that a preferred alignment of hornblende crystals produces a clear schistosity in hand specimens of this rock. This rock is a garnet hornblende schist. It is a metamorphosed mafic igneous rock, that is, an igneous rock that was composed of silicate minerals high in magnesium and ferric oxides.